your source for JVM knowledge.
Good morning. Thank you for coming to this session. Today we're going to talk about how to create Micronaut configurations. I know that there are a lot of people interested in that. Graham spoiled a little bit of this talk yesterday, but I think that, or I hope that you learn something new today. Before going into any details, let me introduce myself, because I will do it very quickly because I know that most of you already know me. I'm Iván López, Ilomar on Twitter. I work at Object Computing. OCI, you know, is the company behind both Grails and Micronaut frameworks. I'm part of the development team. I run the Madrid Groovy user group. We are the biggest and most active Groovy user group in the world. We have more than 5 years of recorded talks on that URL. If you know Spanish or if you want to improve your Spanish, you have plenty of options to choose in that madridgoog.com website. I used to organize this conference for the past 5 years, but now we needed, Alberto and me needed to take a break, and for this year, Sergio and Jose Miguel are doing a fantastic job. And I'm also a regular speaker at different conferences. So let's start. The title of this talk is, so it's creating Micronaut configuration, but what is really a configuration? When you, for example, use the CLI to bootstrap to create the skeleton of a Micronaut application, you can pass those features, any of those, or a lot of them. Discovery Consul, management, Graal native image, tracing with Zipkin. We have a lot of them. All of those are configurations or features, so I'm going to use both words during the talk. And basically a configuration, it's something like an integration with a third-party tool. If you know Spring Boot, they call that starters. These are the same. Are integrations with third parties to make your users or to make users happy or be able to provide them a way to integrate that tool inside Micronaut. So you can see we have plenty of them now. Oh, it's flicking again. So we have integrations for Discovery Consul, Eureka, Graal, Flyway, Hibernate, Gorm, management, Micrometer, Postgres, Rabbit, a lot of different things. So all of these are out of the box for you, but sometimes you need more, or you need to integrate with a new tool or with some third-party library or API. So basically, to do that, the only thing you need to do is something like just creating beans, right? You use some library, and that library exposes some Java classes that you want to use inside your Micronaut applications. So it's pretty much create a bean, a Micronaut bean that can some kind of grab that library and be able to inject that Micronaut bean inside your controllers or your services or whatever. But the thing is, it's not like that. It's not also or only creating beans. It depends on how complex is the library you want to integrate with, because sometimes the library is pretty simple or it's just a small library or tool, so you can just create a few beans, but in other times it's a really complex way or a really complex library. So when you create a configuration, you have a lot of options that Micronaut offers you to do that. So you can create bean factories to create these beans, these Micronaut beans. You have conditional beans. You can replace a few beans. So this is useful if you want to, for example, replace one bean that Micronaut provides to implement your own logic. You have bean configuration, configuration properties, configuration builder, each property, each bean, and a lot of more options. So what I'm going to do during this talk is I'm going to explain all of this in detail with some code examples. And then in the second part, I'm going to switch to the IDE, and I'm going to show you two different configurations that we have. One is the Flyway for database migrations, which is a simple one. It only has something like 7, 8, 9 classes. And the other one is RabbitMQ, which has something like, I don't know, 50 or 60. So you can see different options and different approaches to solve problems. And please also keep in mind that you can use, or you should use, more than one of these options. So you don't need to only choose one of these approaches. You can mix and merge everything you need to make easier for your users to use this new library that you want to integrate with Micronaut. So are we ready? So let's start by the very beginning. Imagine that you have this full library. This is the library that you want to integrate inside Micronaut. And if this library or if this code is in your source code, the only thing you need to do is pretty much annotate it with a singleton. So with that, when Micronaut compiles that class, we'll create a bin, and you will be able to inject full library inside any Micronaut artifact. But the problem is that you can't do that because you cannot modify that source code. It's in another jar, it's an external tool, so you don't have that option. You only can use that jar on your class path, but you cannot modify, right? So you pretty much go to the square one. So what you can do to integrate or to create a bin is creating a class in your source code and annotating that class with a factory. And with a factory, we are telling Micronaut, we want to create bins in this class, and all the methods in this class annotated with a bin are going to be exposed at Micronaut bins. And the only thing then you can do, so basically you are grabbing this full library or this full class inside a Micronaut full library bin. So now in your source code, you can just inject full library objects, and that's all. It's pretty simple. So this is the very beginning, creating bins from a third-party library. So you need to take a look at the library you want to integrate and see what objects or what classes are the things or the classes that you need to create bins for, because probably you don't want to create a bin for everything, right? Only the classes that make sense for your users to use it. And sometimes what happens is that we want to create conditional bins because so these are bins that are only going to be created when some condition is true. So in this example, we have this JDBC bookstore, and it returns or it needs a data source. So in order to create this bin, we can do something like this. We can annotate the class with @requires, and it's a repeatable annotation, so you can put any number of conditions. And in this example, we are saying, okay, in order to create a bin for this class, in order to create this bin, JDBC book service, what I need is a data source bin, and also I need the property data source URL defined in the configuration. And if any of those conditions in @require is false, this JDBC bookstore or book service bin is not going to be created, because if you don't have a data source, you cannot use it, right? The data source is used on the constructor, so it's no point to try to create this bin because it's going to fail without a data source. And we can use a lot of options. There are this @requires annotation provides you so many different ways to define your requirements. So you can say, okay, I need this class to be on the class path, data source. I need that this class is missing on the class path. So if it is not there, then I'm going to create the bin to do whatever I want. For example, you can say, I need the bin. And please don't confuse classes with bins. The first one, it's just a Java class, and bins is a Micronaut bin, right? So the class is the same because when you create a bin out of a class, the type and the full package name is the same, but one thing is a Micronaut bin and the other thing is just the class. You can say the same. When this bin is missing, I will create it. For example, you can say, okay, if the environment is test, I create the bin. So this is useful when you only want to create some bins for test. Or if the environment is not test, then I use it. Yeah?
Look for a missing class if you're using JDBC raw center class and say it should be missing in the class path when obviously you need it to compile your annotation?
No, you don't need it because Micronaut. So I think Graham told a little bit about this yesterday. I don't know the internals of this.
What you normally do is you set it as compile only?
Yep.
Oh, so
exactly. So you.
Runtime,
yeah. Or provided, depending on the case. So you can compile your code, but on runtime, maybe it's not there. Okay, thank you, Sergio. So environment, or the environment is not test, some configuration, some missing configuration, some SDK, so you can say, this will be only available if you are using a Java 8 or Java 11 or whatever. I think we have enums for Android or things like that. If there are entities annotated with this JavaX persistent annotation, if there is a property defined, if there is a property missing, or if the property has a value, or if not, I'm going to use this by default. And finally, if you cannot achieve what you want with all these options, because remember, you can put any number of requires, you always have one little something like last resort, which is use condition. Then you put a class there, flyway condition, and this class needs to implement Micronaut conditional interface. And then basically programmatically you will define, or you will decide when do you want this required apply. So you need to return basically true or false, and when you return true, this condition or this request will be true, and the class will be, or the bean will be created. Oops, sorry. So beans replacement. So with this option, we can replace beans, existing beans. So imagine that we have this example as the same one we used before. So we have defined our data source, we have the data source URL, but maybe we don't want to use this for, I don't know, for test, because you want to try any other thing or whatever. So what you can do is you can create another class, and you can annotate that class with replaces, and you can say, okay, I'm going to replace the other bean. And with that, you are replacing that other bean, and you can put, for example, here another require saying only for test. So you only apply that for test, and you can replace any bean that is not annotated with at infrastructure. Micronaut has a few beans annotated with that, so you cannot replace, and you can also create beans and annotate it with that at infrastructure, so you won't allow your users to replace those beans. And what you can see here, and we use this pretty much everywhere when testing Micronaut core, is that we combine this with at requires and this spec name. So we use this basically when we want to create a bean with some conditions to test something inside Micronaut core. So we only want to create that bean for that specific test. So we define this spec name, we put there a name, and then when we initialize the context for that specific test, we use the same name, in this case foo, and that bean will only be created for that test. Then on the next test, we may, for example, need to create another bean, the same type but with different behavior, so we can replace, or we can have only that bean created for any of those tests. I will show you an example, a real example on our test suite, or how to actually use that. It's really powerful, and we use that a lot. Okay, bean configuration. A bean at configuration is grouping. It's a group of multiple beans definitions inside of a package. So with this at configuration annotation, you probably want to apply to a package level to tell Micronaut that all the beans defined in that package are a logical group. So you usually put this class in this package info file. So in this example, we are saying that to create any bean declared in this IO Micronaut configuration DB migration flyway package, this property flyway.enable, it's not so it's not to need. Oh, sorry. This flyway enable is not to be set to false. If it's set to false, meaning that you want to disable migrations, then none of those beans are going to be created, because if you want to disable the migrations, you don't need the beans at all, right? And you put this on this package Java info some kind of a shortcut to avoid to annotate all the beans inside your configuration with the same one, right? It's like a shortcut that you put on some kind of top level file. And in this other example, it's the same, but from RabbitMQ configuration. And in this case, you need those three classes, channel, connection, and connection factory, to be present to create any RabbitMQ bean. Configuration injection. So another feature that you want to provide to your users when you develop something, imagine that you are integrating this API service to whatever service, you need to provide your users a way to set those, for example, API key and API secret, right? Because you don't want to hardcode that. So you can use @value, and you say, okay, @value, $curly brace API.key, and that value will be injected at compile time and resolve there. The same way you can do it for API secret. And sometimes you also need to inject a value from configuration, but if the user doesn't provide that value, you need to provide a default value, because for using this service, the user needs to provide its own API key and server, but maybe these results, some kind of pagination results, they are some kind of optional. So you can say, okay, if API.results is there, I'm going to use it, but if not, Micronaut will use 10 by default. So you can use this colon to separate the key, the property key, oh, come on, and the value. And the value. And you can also use, so we are using the colon to separate the key and the value, but if you want to use the colon in the default value, you need to do this. You need to escape the value with backticks. Because if you don't do that, what is going to happen is that Micronaut is going to take a look for API.url. If it doesn't exist, it's going to try to find another value, another key called HTTPS. And if it doesn't exist, it's going to try to convert this, and it's going to fail because this is not a valid property name. So if you need to use colon, you need to use, so if you put a default value with colon, you need to escape with backticks. And we are not restricted to use this, so these kind of placeholders inside at value. You can use that pretty much in any Micronaut annotation, or in any annotation actually. So here we are saying, I want to expose this controller in API, and if the API version is defined, I will use it, and if not, it will be API/v1 by default. Or you can say the same here when you create, for example, Micronaut, if you use the declarative HTTP client, you can say, my API server URL is the one defined on configuration, and if it's not there, I'm going to use this localhost 8080. One thing you need to be aware, and we had a few issues and misunderstanding from users, is that you can see here that we use server-URL. This is called kebab case, meaning all letters in lowercase with hyphen separated words. If you put here a property name in camel case, it's not going to work. So in configuration in your application.yaml, you can use kebab case or camel case. Because Micronaut, what it's going to do is, basically when it reads your application.yaml, it's going to normalize everything in memory to kebab case to basically save memory and improve performance. So you don't need, or Micronaut doesn't need to take, when you define a property, different combinations on kebab case, camel case, or whatever you do. So everything is normalized in memory in kebab case. So in configuration, you have the two options, kebab case or camel case. But here, this only one is allowed because in memory, only the kebab case is there. So we had a few issues, and what we did to solve that or to help users, actually I did it a couple of weeks ago. I created a type element visitor, which is a thing that we use to hook into the compiler. So basically what this element visitor does is, during compilation, when Micronaut is compiling your source code, the element visitor take a look at all your annotations and find these property definitions or the property names. And if there is any property defined in kebab case, it will be okay. But if you define something in camel case, the type visitor will throw an error, a compilation error, saying this property name server URL with capital U in camel case, it's not valid. So please use the same one in kebab case, and it suggests you the right name you need to use. So with this new approach, you don't need to waste your time, or you don't need to wait until runtime to discover that this is not working as you expected. Now Micronaut provides a way to do that at compile time for you, so you save the time or wondering why it's not working on runtime. And actually, yesterday night there was a question on our GitHub channel about exactly this one. The URL was pretty much like this, but that user forgot to use the backticks. So Micronaut was looking for a property / localhost, and that is not valid. And the visitor told the user, this is what you need to do. So what else with configuration injection? You can specify, for example, imagine that you have that on your application.yaml, and you want to inject more than one value. So what you can do is do something like this. You can use a property and define some key, in this case the APA default properties, and everything behind that key will be basically exposed or available inside this object. In this case, it's a map with a string and object, so it's pretty much a box, and you shouldn't pretty much. So what I'm going to try to say in this slide is, you have this option and to put a map if you want, but please don't do that, because it's an object and it's a map, so you can put anything there, and it's not the recommended approach. So the recommended approach to have this configuration externalized is to use configuration properties, because with that we provide a type-safe way to read and to maintain configuration values. So you can create a POJO like this, just a plain Java class with getters, setters, everything, and you annotate it with a configuration properties, my engine. And now everything behind or inside this key will be mapped to the properties using getters and setters in this class. And Micronaut will produce reflection-free configuration classes for this to access at runtime without actually doing reflection. So you can also do with this approach things like that. You can annotate using the validator API. I need that this is not blank, or I need at least the value, it should be at least 1. And you can also create nested properties, creating static inner classes and annotated them with configuration properties. So with this one, what you have now is that you are going to map that application YAML to that class, or the other way around. And the nice thing is that you have types, so you have defined an integer, you can put dates, Boolean, anything you want, and you have type-safe configuration classes, instead of using the other approach in the previous slide with the map, in which everything are objects and you are not sure about the types, right? And another super useful feature that I discovered later when I was working on the Flyway configuration was this configuration builder. So imagine that you have a class provided by that library that you want to integrate with. So in this example will be something like engine imp builder, and that class that you have not control of it, it's used in that library to basically read the configuration from that library. So what you want to do so you want to use that class because in that class, the maintainers of the library already do everything to read the configuration, but you can take advantage of that. So what you need to do is annotate that, you define that class, and you say, okay, this is going to be a configuration builder. And this tells Micronaut that so basically, please use this class to read the configuration and to map all the properties in this class from the configuration. And here you can also define the prefix. In this case, we are using with, because in this example, all the methods to set everything or to read everything, it start with. So with manufacturer, with cylinders, with whatever, right? So if you have getters and setters, you don't need to do that. You can leave the prefix just with an empty string. And you can also define this configuration prefix, which means that this is the prefix that you want to use in your application YAML. So if we have this, we can use this. So this configuration prefix will be used there. Even it doesn't matter. So in this example, the name of the property is the same, but in camel case. But if you put here crankshaft / grid, then there you need to put crankshaft / or dash grid, right? This is how it maps. And the same for this other property. Okay. So now let's imagine that we have this class, and what we can do, so we learned in the previous slide that we can annotate it with configuration properties, but there is a problem. What happens if we have more than one data source? Because in Micronaut, you can define more than one to connect to books database, to users, logins, audits, whatever you want. So here you are injecting a data source, but maybe you have defined 5 of them, and you want to have, in this example, a flyway migration per database, which actually makes sense. So what you need to do is annotate this class, these configuration properties, instead of using @configuration properties as we saw before, you need to annotate it with @each property. So what Micronaut is going to do is it's going to create, or it's going to iterate through your flyway.datasources.whatever. And that whatever, it's the name for you as a user. It's a name that makes sense. So you can say flyway.datasources.books, and then all the properties for that. And then another property, flyway.datasources.users, right? So these books, users, that's the name that will be stored here as a parameter. And Micronaut will create, in this example, flyway configuration property beans with that name. And you will use that name later to basically know for which data source you want, so for which data source this flyway configuration object is some kind of linked. Right, so this is what I said. Flyway data source is default, flyway data source is books, right, and that name will match that. Come on. So the qualifier is default, and here for your other one it will be books. So this default name, it's the one we use internally in Micronaut, so when you only have one, but it's not a special name. So you can put any name you want. You can say flyway data source, books, users, audits, anything you want. So it's not mandatory to use default for the first one, right? And then after we annotate the class with its property, Micronaut will create one bean per configuration property. So in the previous example, one for books and the other one for the default data source. But how do we inject that? Because now we have more than one bean. So what we need to do is just inject a collection, and that's all. We are defining the property there, and we use constructor injection, and Micronaut will inject that list of all the available configuration properties that we created with the at each property. It can be 1, it can be 11, it can be 0, right? But it's a list. And then if you want to retrieve one of those beans, you can do something like this. Application context, find bean, the type, flyway configuration properties, and then qualifiers by name and the actual name that you use or the user used in the application YAML file. So you can put here books, default, audits, and again, anything you want. With find bean, you see that the return type is an optional because the bean may or may not exist. And if it doesn't exist, this will be an empty optional and nothing will happen. If you want to get a bean and you know for sure that the bean exists, instead of using find bean, you can use get bean. But if the bean is not there, you will have Micronaut will throw an exception. So depending on your case, you may want to use find or get bean. And finally, the last piece of the puzzle is this. We have created multiple configuration properties with at each property, but how do we associate that with our factory? Remember, in the first slide, we have the factory. So now what we use is each bean, and this is going to be just like the same. Micronaut is going to iterate in all the flyway configuration property beans, and it's going to inject any different bean per some kind of iteration. And in that code, so here we are not using the qualifier, but you could do something like config.getNameQualifier, because that's the property name that I used in the other slide, to get the qualifier if you need it. And as I said before, you have here the option. If you want to get these flyway beans, here I'm using get, so I know that the bean exists, and I can do the same qualifiers by name, book, and I will get a flyway bean. And this flyway object is the same class, so it's the class from flyway library, but this one is a bean, so it's grab something like a Micronaut a bean. So I saw you in something like 25 minutes, even more, the more important options that you have or approaches that you have when creating these integrations, but there are even more things that you can do in a configuration. So you can create HTTP filters, you can expose endpoints to, for example, in the flyway library, we have an endpoint to expose to the users all the migrations available on the database. You can use aspect-oriented programming. Graham told a little bit about that yesterday. So, for example, the HTTP client is done with this AOP. The Micronaut provides a really powerful API, reflection-free, to do AOP. You can use or define a notation mapper. You can expose controllers. For example, the security feature expose a login controller for you to basically be able to log in into the application. You can define your own events and fire events when something happens, and you can even execute something on a startup. So you have plenty of options. So what I'm going to do now, I'm going to mirror my screens, and I'm going to try to show you some code if the projector works. which is a big if. Okay. So this is the flyway configuration, and as you can see, it's pretty small, only a few classes, something like probably less than 10. So let me show you a few things. So we have this package info Java. So this is the package info. It's annotated with that configuration, and as I show you in the slides, this means that I need flyway enable not be false to create any bean defined in this package. If flyway.enable is false, nothing here or nothing, any bean here will be created or processes or nothing at all. Then I have my configuration properties, annotated again with each property, and here you inject, you define anything you want. The data source, the qualifier, remember these books, authors, whatever, and some properties, and here there are getter setters. So this is the constructor I show you. You need to annotate both of them with a parameter to let Micronaut know that this is from a configuration properties and these parameter names need to match. And here we have this fluent configuration. This class, it's from Flyway, and as you can see here, there are a lot of getters. So this is the class that Flyway uses to read the configuration. You can customize a lot of things. So instead of basically mirroring this class inside the configuration, what we do is define that property, annotate with a configuration builder, and the prefix here is just an empty string because the Fluent configuration object use getters. So just with these things, we are able to read all the configuration, everything defined here, it's read automatically from the application.yaml. So if you define this license key, installed by, or whatever any properties that you have here, it will be read automatically by Micronaut from the application.yaml. What else? This is the factory I showed you before. So create a class, annotate with a factory, and for each bean that we have defined before with this configuration, we are going to create, we need to return a Flyway, and this is again a class from Flyway. So this is how we create Micronaut beans using third-party classes. So this load method actually returns a Flyway object. What else? Yeah, the condition. So remember that I showed you before that we had here this at requires condition, Flyway condition, right? This was the last option that you have to check if you want to create this bean. So in this case, in this Flyway condition, what I'm doing here, basically I get the name. If it's there, I get the configuration properties, the bean if it has been created, because you can disable the migrations for one data source. And then if there is no data source, this won't be processed, so I return false. And if the configuration is disabled, I will return false, and this won't be processed. And in any other case, I want to make sure that here I create a bean. Because the other option, probably you can think here, put here some logic and return some kind of null if you don't want to create a bean. But that's not possible. If you return a null here, it will fail. So when this code is executed, you need to actually return this Flyway object. So that's why we need that condition to avoid executing this code if we don't want to actually create the bean. What else? What is it? Here we have the startup listener. So this is the one we use to hook into the Micronaut startup process. So we just need Flyway beans, and I am using bean and not class because I want all the code, all the beans in the previous steps. I need all of those steps created. And basically what we do here, I am listening for the startup event to basically hook into Micronaut startup process to run the migrations. So this is how we are doing now, and here I run the migrations. I'm not going to go into any detail. And here we have an endpoint, so we define this endpoint with this name. So if you have the management feature installed, you will be able to access to your migrations and localhost 8080 / Flyway in this example. And here, this is how we get it. This object this info, it's again from Flyway. So basically with this, we have all the information from the database. And we don't need to worry because Flyway will do everything for us. The only thing we need to do is basically call the method and return the right type. So this was all for Flyway. And from RabbitMQ, you can see here that there are a lot of code. So you can see a lot of more code. This is a more complicated integration. So I'm only going to show you a few classes. So again, the package info, I need these 3 classes on the class path to actually execute anything here. And another thing that configuration can provide or can contribute to are, for example, to the health indicator. If you have, again, the management feature installed, you have an endpoint called localhost 8080/health, and by default, it will just return app if your application is running. But if you have a RabbitMQ, a database, something like that, you can also probably want to contribute to this health endpoint with the status of all those options or all those pieces of architecture that you are using, because if the database is down, the application probably won't work. So with this health indicator, we are hooking, this is the default value, it's up. So basically, we can check the status of RabbitMQ, and if it is down, we can report that in the health endpoint. What else? Connect Rabbit connection factory. So this is again a factory. It's been, and here we return again this connection object or this connection client, which again it's from RabbitMQ library. So we basically it's grabbing things from library and customize everything to make your user's life easier. We have here in the annotation, we have the Rabbit client. So this is an annotation. If you know Micronaut HTTP client, you know that you can annotate an interface with a client, and Micronaut is going to generate the HTTP client at compilation time for you. This is exactly the same, but for RabbitMQ. You can define an interface, annotate it with a Rabbit client, and all the methods in that client will be implemented to basically send messages through RabbitMQ just for you. The only thing you need to do in your application is inject that client, and that's all. So that's one of the ways of make your users happy or the life easier, because the users don't need to deal with RabbitMQ client or low-level client. They just use the same thing they are used to, like Micronaut HTTP client. Now they have Rabbit client, same behavior, an interface, and that's all. And if you are curious, this is implemented using this AOP thing, this aspect-oriented programming, using an introduction advice. This code is more complex than the others. And this is what is executed basically when you send or when you call a method on the interface. So if you are curious, you can set a breakpoint here and debug the code to see how actually it works. It's pretty interesting how everything works. But I'm only going to show you here, that at the end, what we do is something like this. Publish and reply, or because this is for RabbitMQ RPC, or just publish, which is something like fire and forget. So we hide everything inside this, and we implement that everything here, so our users don't need to do that, don't need to worry about how this works. We care about that. So with these approaches, you make your users happy, right? Because they only need to define an interface, and that's all. They don't need to worry about all these low-level details if they don't want to. What else? I need to finish metrics. So the last thing I'm going to show you here, these are the metrics. So again, if you have the Micrometer dependency there, you can provide some metrics information, and this metrics interceptor will provide that information for you. And the last thing I'm going to show you that I forgot before is I'm going to show you this test. Remember what I said before about the spec name? So I define here the spec name, spec event listener.simple name, which is basically the name of this class. And then this is my configuration. I check everything, and here I create a bin, and this bin will only be created for that specific test. So if here in this class I have more than one test, this bin will only be created for this one. And if I have another test, I can create another bin with different conditions to test whatever I want to test, right? So this approach, if you find for this inside Micronaut core, it is used pretty much everywhere. So I need to wrap up. So as a summary, Micronaut provides a lot of configurations and features out of the box. You saw in the first slides these 3 columns with a lot of things, and we integrate with more and more tools in every release. It's easy to create integrations. Some of them are easier, some of them are not that easy. The RabbitMQ, it's complicated. Kafka integration, it's even more complicated because Kafka has even more options than RabbitMQ, but you can start easy. And it's so with these configurations, you can extend the framework, right? It's a nice way to basically integrate with anything you want. And as Graham said yesterday, this is the way we recommend now. So if you plan to write a Grails plugin, please don't do that. Write a Micronaut configuration, because with a Micronaut configuration, you will have the option to integrate that tool, that library, with Micronaut, with Grails 4, and with Spring Boot if you use this Micronaut for Spring library. So with working only one way or one time, you can integrate with the 3 frameworks. So this is the approach that we recommend now. You saw a lot of different options. So you have plenty of options to define or to do what you want to do and to decide what you want to do. And basically, the sky's the limit, because in the Rabbit example, I show you that we created this at Rabbit Listener, at Rabbit Client to send message through RabbitMQ, implementing the interface. And also there is another annotation which is at queue. So in any method you have, you annotate it with at queue, put the name of a queue, and that's all. That will connect to RabbitMQ and start listening to that queue without you needing to worry about that. So that's, again, a nice way to provide an integration for your users, but maybe, so it's an advanced technique, but you can start with more simple things, and then you can add more and more as you need. And basically, it's everything about increased productivity, makes, again, your users happy when they want to or they need to use that third-party library inside Micronaut application. So that was all. This is my contact information. I'm going to push the slides, and please remember to send feedback using the official one. But if you have something like 30 seconds, please go to that URL, bit.ly/Micronaut, or in this QR code, it's the same URL. It's an anonymous Google form, so it will only take you something like 30 seconds. There are 4 questions to send me some feedback about the talk. If you like it, let me know. If you didn't like it, also let me know. You can say anything you want. I won't be offended. It's anonymous, so say anything you want, but give me some feedback. And now I think we have a couple of minutes for questions. Thank you.
Questions?
Any questions? Sergio.
Can you maybe extend a little bit about what kind of lifecycle events you can plug into as a configuration?
What lifecycle do you?
Lifecycle, you know, when you create a Grails plugin, you can plug into different stages of the application, startup, shutdown, and configuration, and all that. What is available in Micronaut in the event listener?
Yeah. So with this, with that event listener, you hook into. So basically, I'm listening for an event. I was listening for a startup event. Now I'm working on redoing that part because we want to execute migrations before the service has started. But with that startup event, you can hook into the execution. So that startup is something like the bootstrap we have in Grails. When everything is starting, you can hook to create data, for example. And then all the beans that you annotate with that singleton will be created on demand. But if you want to create some bean when the application starts up, you need to annotate it with that context, which means that it will be created eagerly. And the rest of the beans are created pretty much when you need it. So you have, so you don't have phases, but they can be, or they will be created as needed.